A block of mass m is pushed against a spring of spring constant k fixed at one end to a wall. The block can slide on a frictionless table as shown in the figure. The natural length of the spring is L0 and it is compressed to half of its natural length when the block is released. Find the velocity of the block as a function of its distance x from the wall. So when the spring is compressed to half of its length, then its energy will be equal to, suppose we write it as U1, that will be half times K times compression square. So compression L0 by 2 whole square. Now, suppose it is at distance x now, so compression will be still L0 minus x. So suppose at that time velocity is v, then total energy will be, suppose U2 equal to half mv square plus 1 by 2 k, and the compression this time will be L0 minus x whole square. According to energy conservation principle, the two energies must be equal. So 1 by 2 k L0 square by 4 must be equal to half mv square plus 1 by 2 k times L0 minus x whole square. So we can find the velocity. So 2 will cancel out. Now we can write mv square equal to k L0 square by 4 minus k L0 minus x whole square, or velocity. For getting velocity, we have divided the equation by m and then taking square root. So we can say it is equal to k upon m, because k will be common from these two terms, k upon m times L0 square upon 4 minus L0 minus x whole square. Now, when x equal to L0, in that case, this term will cancel out and we will get velocity as k upon m square root times L0 square upon 4, which will give L0 upon 2 times root of k upon m, and that is our answer. Consider next question. A particle is placed at the point A, particle is here, of frictionless track ABC, as shown in the figure. It is pushed slightly towards right. Find its speed when it reaches the point B. Here, point B is at height 0.5 meter, whereas point A is at height 1 meter. But at point A, particle has no velocity, so only it has potential energy. And at point B, particle has velocity also. So suppose velocity is v at this point, and it is at height 0.5 meters. So both energies will be there. So according to energy conservation principle, energy at A must be equal to energy at B. So mgh, h is 1, equal to mg into 0.5 plus half mv square. Mm will cancel out. And now we can put the values. G we can take 10. So this is 10 minus 10 into 0.5 equals 1 by 2 v square. So this will give 5 to the 10. This will give 5. This is 10. So 10 minus 5 is 5 multiplied by 2. Square root will be equal to v. So v equal to root 10 meter per second. Now consider next question. Figure shows a smooth curved track. Figure shows a smooth curved track terminating a smooth horizontal part. So this is track. Here it is smooth, and there is a spring whose spring constant is 400 Newton per meter. is attached at one end to the wedge, fixed slightly, fixed rigidly with the horizontal part. A 40-gram mass is released from the rest at a height of 4.9 meter. So here height is 4.9 meter and mass is given as 40 gram, 0.04 kg. Now this is released from the rest on the curved track. Find the maximum compression of the spring. So energy of this mass at this point must be equal to energy of spring. So it is simple question. We can say mgh must be equal to half kx square. So we put the values. M is given 0.04. G we can take 9.8 or 10 into height. Height is given as 4.9 equal to 1 by 2. Spring constant is given as 400 into x square. This will become 200. Now we can divide it 0.04 into 9.8 into 4.9 divided by 200 square root is equal to x, which can be simplified, and this will become 9.8 into 10 power minus 2 whole square. So it is better to write other way around. So don't write like this. Here we can convert all numbers, like we write it 4 upon 100 into 98 upon 10 into 49 upon 10 into 200. Here 2 and this will become 100. So what do we get? We get 98 square in numerator and in denominator 20304060. So we can say this is 1000 square with the square root. So this will become 98 divided by 1000, which is equal to 0.098 meter or 9.8 centimeter. And that is our answer. Thank you for watching.